Welcome to Integrative Nutrition for Life video presentation.
mTOR, the mechanistic target of rapamycin, is a central nutrient and energy sensor that determines whether cells grow or conserve resources. It integrates signals from amino acids, ATP levels, growth factors, oxygen, and cellular stress. Based on these inputs, mTOR decides between building new tissue or activating repair and energy-saving processes. mTOR exists in two complexes. mTORC1 is the primary growth switch, promoting protein synthesis, cell proliferation, fat production, and ribosome formation. It is activated by amino acids, especially leucine, along with insulin, IGF-1, and high energy availability. When mTORC1 is active, autophagy decreases and growth programs dominate. mTORC2 supports long-term cellular stability. It regulates cell survival, cytoskeleton organization, glucose metabolism, and AKT signaling. Although less understood than mTORC1, mTORC2 plays a crucial role in maintaining cellular structure and metabolic balance, helping cells adapt to changing physiological conditions. mTOR strongly influences mitochondrial function. When active, it supports growth programs that increase mitochondrial protein synthesis and coordinate energy demand with cellular expansion. When inhibited, autophagy and mitophagy increase, allowing damaged mitochondria to be recycled. This balance helps maintain mitochondrial quality and long-term metabolic efficiency. mTOR directly controls autophagy. When mTOR is on, autophagy is suppressed. When mTOR is off, autophagy and myophagy activate. These cleanup processes remove damaged proteins and mitochondria, supporting cellular repair. This constant balance between growth and recycling is essential for maintaining healthy mitochondrial networks. mTOR is central to aging research. Chronic high mTOR activity is associated with accelerated aging in many models, while periodic reductions through fasting, calorie restriction, or exercise are linked to longevity. These interventions shift cells toward repair, recycling, and improve mitochondrial quality control. mTOR interacts with major metabolic regulators such as AMP-Concert1. AMP promotes energy conservation and repair, while mTOR drives growth. Their balance determines whether mitochondria operate in high-demand mode or shift toward maintenance. This regulatory network helps align energy supply with cellular needs. Nutrients and lifestyle strongly influence mTOR. Amino acids, insulin, and high-calorie intake activate mTORC1, while fasting, exercise, and certain plant compounds modulate it. These inputs help determine whether cells prioritize growth or repair, shaping mitochondrial turnover and overall metabolic health. mTOR does not participate directly in mitochondrial metabolism. It does not generate ATP or function in the electron transport chain. Instead, it acts as an energizer and manager that coordinates mitochondrial biogenesis, activity, and recycling. By regulating growth and repair, mTOR helps maintain long-term cellular and mitochondrial resilience. Like, subscribe, and hit that notification bell so you never miss an update. We're dropping fresh videos often to keep the momentum going. Share your health goals in the comments and let us know what topics you want next. Let's build unstoppable energy and vitality together. Your journey starts now.
Do you have questions, comments, or want expert health tips? Visit the website integrativenutritionforlife.com and reach out via email today. Connect with a very smart, knowledgeable, triple certified health coach ready to help you improve your health and well-being.